Hello, today we're going to continue with the binomial distribution, which is our new way of using probability and the binomial expansion to model probabilities of anything that happens a repeated number of times. So we're going to start on a quick recap of last lesson. If you want to have a go at this, feel free to pause it because I'm going to go through this in a minute or so. So here we have a biased coin which is tossed 12 times, and the chance of getting a head outcome is 0.6, and we're asked to find a couple of probabilities. So, first things first is to work out what is n and what is p. So in this case, x is going to be modeled by a binomial 12, which is n, and then 0.6, which is p. So this is just a way of saying we're using binomial distribution, where n is 12, so we're doing 12 possible repeats, and 0.6 is our probability of success. So the first one, probability x equals 8, we're going to use our calculator to work this out. So if you want to pause this, have a go at it yourself, and then we can see if you can do it. Okay, on your calculator, instead of using the binomial expansion, we're going to use a version of this on our calculator. So we're going to press menu, we're going to go to distribution mode, which is mode number 7, and we're going to go on binomial probability distribution, which is 4. Variable, because we only want to find one thing. Put in 12. We're not going to put in 12, we're going to put in 12 for n and 0.6 for this, and the value we're interested in, we're after x equals 8. So we put in 8, 8, 12, 0.6, we get 0.213. So there's a reasonable chance of getting 8 heads if we do this. If it was a fair coin, we'd be expecting 6. So there is a reasonable chance of getting 8, because we're having a slightly higher probability of success than just our 0.5. To do 11 heads, we're going to have to put 11 in here, so I'm going to press equals again, it goes back to this mode, we're going to put 11 in for x. Press equals again, we get this 0.0174. Quick reminder on 3 significant figures, here we had to go an extra place here because the first one is a 0. For the last one, more than 10 heads. X is greater than 10. So greater than 10 means probability x equals 11 plus the probability x equals 12. Think for a second why we don't have to go any higher than 12. We're actually only doing this 12 times in the question, 12 times of coin tossing, so we're going to stop at 12. So for this, I've got my 11, which is 0.0174. So I'm going to use my calculator, going to press equals again, go back, put in 12, press equals, I get this number which is in standard form. So this is 2.17 times 10 to the minus 3. Adding these two things together, which you can do on a calculator, it will take this number and call it ants. So if I go back to menu 1, so we've got that number, I'm going to add on my 0.0174, press equals. I get this answer, which is 0.0196, if we round correctly. So we use this to work out some binomial probabilities. So this is all about this many attempts, this probability of success, what's the probability of getting each of these things. Before we move on to the next thing, probability x is less than or equal to 7. Just have a quick think about this. In order to work this out, we'd have to do 7 and 6 and 5 and 4 and 3 and all the way down to 0. So this would be a lot of steps. What we're going to have a look at in the first part of today's lesson is the cumulative distribution, which lets us work out not equal to, which we worked out for this one here, for this equals 8 heads, but less than or equal to, which we can use to calculate things like this very, very quickly. Okay, so this is the cumulative binomial distribution. So this is either done on the calculator. If I go menu, I go to distribution, I go on the down arrow here, and then go on option 1, I get binomial CD, which stands for cumulative distribution. And it looks exactly the same as it did before, but it says binomial CD at the top. So this is cumulative. This is going to do not x equals, but x is less than or equal to. So this CD here, binomial CD, is probability x is less than or equal to something. Whereas previously we did x equals. There is a version of this in your formula book. Here's a formula book that I've borrowed from college, even though it says class copy, whilst I have it in my house. So in this one, we get the cumulative distribution as a table. So all this is a whole load of numbers that you could reproduce with your calculator. You have to look up n here and look up p here, and then you can use it to find out. So this one here is 2 or less. But we're going to do all of this using the calculator, but if you do want to use the formula book, I will show you how to do it. Okay, so here we get given a binomial distribution of n is 20 and p is 0.4. So to do this first one, which is probability x is less than or equal to 7, we're just going to look up 7 on our calculator. So we're going to go to binomial CD, we're going to put x in as 7, n in as 20, and this one in as 0.4 for probability. Remember, this is always n first, then p afterwards. Press equals and we get an answer of 0.416. So this, because we used binomial CD instead, notice it says CD at the top, it didn't do 7 by itself equals 7, it did up to and including 7. For the next one, for B, we're going to do probability x is less than 6. Now this doesn't include 6 because there's no equals on it. So actually, if we were to write out the numbers we're using, this is 0, 1, 2, 3, 4, 5, 6, 7. We want these numbers here. We do not want 6 because there's no equals on this. So this one, we're going to write equals probability x is less than or equal to 5. So you'll notice here this one doesn't have an equals, it doesn't include 6. This one we do write with an equals, it includes the 5. So we're including 5, so that everything less than 6. So this one here I'm just going to change my 7 to a 5, run this through the calculator, and I get 0.126 as my answer. For the last one, for part C, we're doing probability x is greater than or equal to 15. I always find with these it's easiest to draw it, so I have 13, 14, 15, 16 and some dots either side. So here are some of my options, and I want greater than or equal to 15, so I want these ones here. So what we're going to do here is we're going to do 1 minus probability x is less than or equal to 14. Because these are the options I don't want, and if you remember back to your probability, we can do not by doing 1 minus. So we're starting at 14 here, not 15. If I put a 15 in here, I would go all the way up to there and I would lose this option for 15. So we're going to do press equals, we're going to do 14 in here, which is going to give us this 0.99. You can just on your calculator, so there we are, there's a 0.9984. On your calculator you can just go back to the normal mode and it preserves your answer. So we're going to do 1 minus ans, which gives us this number here. So we get 1.61 times 10 to the minus 3. So feel free if you want to write out some numbers and work out exactly which numbers are involved. So here to do less than 6 we stopped at 5. To do this one, which is greater than or equal to 15, we had to do 1 minus all the way up to 14 because we don't want any of these numbers. Here we have a question in context. They've given us a spinner, which is an unfair spinner. It's got a probability of landing on red of 0.3. And Jane has 12 spins. So find the probability Jane obtains no more than 2 reds. So let's start writing what distribution we've got. So we've got X is modelled by a binomial, 12 attempts, 0.3 for success. And we want no more than 2 reds. So we want probability X is less than 2, less than or equal to 2. Because this means up to 2, no more. So actually this one we can look straight up on our calculator. So this is A. No more than, so that's 0, 1, 2, x is less than or equal to 2. So we go to distribution mode. You will get used to swapping mode all the time. If we did PD, we'd just work out equals 2. So we're going to use CD so that we can get up to and including 2. So x is 2, up to including 2. N is 12, and this is 0.3. Press equals and we get 0.253. For part B, we want probability that x is greater than or equal to 5. At least 5 reds. So 5 or more reds. If we think about our numbers 3, 4, 5, 6, ... we want greater than or equal to 5. So we want to include 5 and 6. So we're going to do 1 minus probability x is less than or equal to 4. So on my calculator I'm going to look up 4. I'm going to put in 4, press equals again. So we want to do 1 minus this. So I'm going to go menu 1 minus ants, and we get our 0.27. 0.276. 2 answers, 3 significant figures for our stats answers. Jane is going to decide to use this for a class competition, and she wants the probability of winning a prize to be less than 5%, less than 0.05. So she doesn't want many people to win this. Each member of the class has 12 spins. Find how many reds are needed to win a prize. So what we were after here is how many reds before the chance of winning becomes less than 5%. So I'm just going to make some space. So let's start with a guess. What about probability x is greater than or equal to 10? Let's have a look at 10 and see if 10 wins is enough. So with our calculator, remember this is 9, 10, 11. So for this one, we're going to do 1 minus probability x is less than or equal to 9. Because this will give us 10 or higher. So we're going to have a look at this and see how this compares to 5%. So I go menu, distribution, I'm going to go on binomial CD, variable. We've got x is 9, n is 12, this is 0.3 from our question. And this one, if we did menu 1 minus answer, gives us a number that's far too small. So let's try probability x is greater than or equal to 8. Which if we think about it is 7, 8, 9, ... So this is 1 minus probability x is less than or equal to 7. Because we want everything here, so we want to take off this other bit. So this is, we're going to go back to distribution mode. So back to distribution mode. We're going to go on binomial PD, which is option number 1, back on variable, and it's cleared all our information. So we want 7 here, because that's what we decided in here we're going to use for our cumulative bit, and then we need to do 1 minus. 12, 0.3 equals, this looks like it's going to be about 1%. So if I do menu 1 minus ants, this one gives us pretty much 1%. If you ever look at this number and go, is it 1%, just add 1 to it. So yeah, it's 0.09. 0.09. So let's try x is greater than or equal to 7. Because this one was quite close. Let's see what happens when we do 7. So reminder that this is going to be all of these things here. So we need to do 1 minus 6, menu, distribution, binomial CD, which is option number 1, variable. Sometimes you get lucky and you land on it straight away. Sometimes it requires a little bit of trial and error. So we've got x is 6 for this one, n is 12, this is 0.3. This looks a bit more like 5%, so we're going to do menu 1 minus ants to do our 1 minus. So this one is 0.0386. So this is less than this 0.05. We should probably have a look at the next one. X is greater than or equal to 6. So this one is going to be 1 take away 5. We can see the pattern here. If we want to do 7, we have to take away less than or equal to 6. For 10, we did less than or equal to 9. Distribution, binomial PD, for binomial CD for cumulative. So we're going to do 5, 12, and 0.3, our information from the question. And then we're going to do menu 1 minus answer. So this one here would come out to be 0. Missed a decimal place here, 118. So we've done quite a lot of calculations here. If we did 7 spins to win, we would get a probability here of 3.86%. If we did 6 red spins to win, we would have an 11.8 chance of winning. The correct answer here, how many reds to win a prize, is 7. So would need because this 7 reds is the first time where 7 or more, because remember you get a prize if you get more than 7, it gives you a probability less than 5%. So if you went for 8, the chance of winning it will be less than 1%, which would put everyone off playing the game really. This one went into standard form. So this one is a bit less than 5%, it's about 4%. This one here, if you went for 6 to win, you'd have 11.8, so almost 12% chance of winning. So this would be 7 red wins for a prize. This one is actually possibly slightly easier if you use the tables, because you can look through the tables and try and find where your 5% is. So if I go for the tables, we need to find n is 12, which is actually on the next page. So n is 12. We've got a probability here of 0.3, and we can start looking through here to see if we can find our 5%. So it's going to be here, 0.95. So this would have given us a better answer of where to start from. So we should have started looking at 6 or 7. Whereas by guessing here, we started on 10 and 8 and kind of narrowed in. So sometimes you'll find the formula book is quite useful. Quick reminder, there's a virtual version, an online version of the formula book in the resources section if you want it in Moodle. Quite a lot of these questions are very, very similar. These test your ability to do binomial PD, which you remember is for the equals, or binomial CD, which is the cumulative one for the less than or equal to. I would suggest you either do question 1 or 2, and then 3 or 4, question 5 and any other questions after that you want to, because 1 and 2 are quite similar and 3 and 4 are quite similar. That's it for today, but you're going to need this information. You're going to need to be good at this before we go on to the next lesson. So Thursday, Friday, the third lesson this week is going to require you to have had a go at this lesson and completed all of the questions.